So far we have been looking at transverse stability, and in the transverse stability, central points is the distance from the keel to the vertical center of gravity to the metacenter, and also central is the shape of the GZ curve, the curve for the writing arm. We are now going to look at longship stability, longitudinal stability, and this involves looking at finding out where the longitudinal center of gravity is and the longitudinal center of buoyancy. A lot of this is similar to the transverse stability, but there's also some differences. We start with draft and trim, and draft is the distance from the keel to the waterline. You measure it forward and aft at the draft marks. Also, sometimes you have draft marks midships. Trim, abbreviated T, is the difference in draft forward and aft. If you have more draft forward than aft, you say that you have a forward trim. Draft forward, often abbreviated TF, is the draft read on the draft marks forward. Draft marks looking like that. You measure it there. Draft midships, often abbreviated TM, is draft read on the marks midships. And that is the draft you use when you're taking out the displacement and other factors from the stability data for the vessel. And draft aft, abbreviated TA, is the draft read on the draft marks aft. Trim, T, equals draft forward minus draft aft, and you say it's forward trim if the draft is bigger forward and aft trim if it's bigger aft. LCG, longitudinal center of gravity, that is the longitudinal center of gravity, and for most vessels it's measured in meters from the aft perpendicular, and the aft perpendicular is typically the rudder shaft. This is not the case for all vessels, as we shall see. So LCG measured typically from the aft perpendicular. Longitudinal center of buoyancy, LCB, that is the longitudinal center of buoyancy, the center of the volume of the hull that is at any given time submerged in water. You can find this in the stability data for the vessel, and it's also given in meters from the aft perpendicular typically. BG is the distance between B and G. So the distance between longitudinal center of buoyancy and the longitudinal center of gravity. And the bigger this distance is, the more trim we have. If the draft aft is bigger than the draft forward, we say that the boat has aft trim. In this case here, draft forward 3.2 meters, draft aft 3.5, which gives us a trim of 0.3 meters aft. Aft trim means that the longitudinal center of gravity is behind the longitudinal center of buoyancy. And this distance means that you have a moment that's pushing the boat down at the stern. So the gravity pushes downwards, the buoyancy pushes upward, and it causes the boat to heel aft. The opposite with forward trim is if the draft forward is bigger than the draft aft, we say the boat has a forward trim. In the example, we have draft forward 3.5 meters, draft aft 3.2 meters, which gives us a trim of 0.3 meters forward trim. So, and a forward trim means that the longitudinal center of gravity is in front of the longitudinal center of buoyancy, and this arm causes a moment that's pushing the boat down at the front, as we can see here, very logically. In order to find the displacement based on the draft midships, you read the draft forward and aft, and then you calculate the average. So if the draft forward is 3.9 meters and draft aft is 4.3 meters, you get the one plus the other, divide it by 2, and you get 4.1 meters of medium draft. In order to find the displacement, this is the draft that we go into the stability data with. So in this case here, draft 4.1 meters, we see that you have a displacement of 2,791 tons, and also then other values there. An example, draft forward 2.56, draft aft 3.18 meters. Then what is the medium draft? 1 plus the other divided by 2, and you end up with 2.87 meters. The other case is if you know the displacement and the trim, but you want to find and you want to distribute the trim forward and aft to find the draft forward and aft. So you know the draft midships. You want to find what it is forward and aft. In the example, we have a medium draft of 3.6 meters, 60 centimeters of aft trim. What is then the draft forward and the draft aft? In order to distribute the trim, we have to split it in two. And draft aft is draft midships plus or minus half the trim. So we say that half the trim is on the forward part of the ship and half of the trim is on the aft part of the ship. That's why we have to split it in two. So in this case, where we have aft trim, we'll find that the draft forward is the draft midships minus half the trim, which gives us 3.6 meters minus 0.3 meters. So we have 3.3 meters of draft forward. Aft, it's the opposite. It's 3.6 plus 0.3, which gives us 3.9 meters. And then we control trim equals draft aft minus draft forward, the one minus the other, and we end up with 0.6 meters. And that is what it was supposed to be. So that's okay. Another example, after loading, you have calculated that you're supposed to have a middle draft of 4.1 and a forward trim of 60 centimeters. What will be the draft forward and aft after loading? So that's what we want to know. We do the same thing, draft forward, in this case with forward trim, we add half the trim, so we end up with 4.4 meters. Whereas aft, we have to subtract half the trim, and we end up with 3.8 meters. We control 4.4 minus 3.8, and we end up with a trim of 0.6.